So for today, we are going to be covering fractions, and my voice is getting better every day. So thank you for that. All right, so how this class is going to work is I'm going to not review, but I'm going to introduce some concepts in fractions, and then you're going to ask me tons of questions as you normally do, and so keep that up, and I will try to incorporate as many answers as I can as I explain, and then towards the end of class you'll have an opportunity to ask me questions. Now normally, as you know, our math classes are anywhere from 2 to 3 hours long. This one will be done in about 40 minutes. So we're going to be together for about 40, maybe 45, depending on how long my story is. But you got to earn that story. So we're going to work on fractions first. Oh, I meant to tell you, I actually have a new handout I just published yesterday. If you're still struggling with your multiplication tables, you can download this, and I will give you a link to it. And it's got a video that walks you through how you can memorize and quickly know your 20 by 20 multiplication table. Now most people don't do the 20 by 20, most people just do the 12 by 12. So both options are in here. If that's something that you would like, there's a little video that goes with it as well. So I'll make sure you have access to that. Okay, you ready to get started? Okay, so I see you guys are already putting things in. Can we get a story? Yes, but you have to earn it. We have to talk about fractions first. Okay, if I were to ask you, what is a fraction? What would you tell me? So give me a definition, give me your best definition. What is a fraction? Okay, so for example, if I said something like 3, is that a fraction? Well, I guess you could have 3 over 1, but no, typically 3 is not a fraction. So what we're talking about here is a fraction. Fractions are numbers that are part of a whole. Okay, what do I mean by whole? A whole number is something like 1, 2, 5. 0 is a whole number too. 7, a million. Okay, so those are all whole numbers. 99. Okay, so if you have any part of that, maybe 3/4. That would be a fraction. Or 1 3/4. This is the whole number part. Let me get another color here. This is 1, that's the whole number. And then here's your fraction, the 3/4. Okay, so hopefully that's not new. That's something that you are comfortable with. All right, so let's talk about fractions in general. So if I were to put this down, you tell me which number, the 3 or the 4, is the parts that are possible. So if I have in here a chocolate bar, does it have 4 divisions or does it have 3? Yeah, it has 4 divisions. Well, let's see if I can make them even. All right, so you have a chocolate bar here. How many pieces did you eat? You ate 1, 2, 3. So that's 3/4 of a chocolate bar that you ate. So 3 is how many we're talking about, and 4 is the total number of possible divisions. Okay, so far so good, right? Put a smile on your face. I gotcha. Yes, we're good. Okay, good. Feel free to turn on your videos. This is just us today. So yeah, it's just us. Hi, I know I can see you, Sophia. Hello. Oh, I see Christine now. I see Ruth and another Sophia. Excellent. And I see Chuck and Ivory. Excellent. And Anton, you're up there somewhere, right? Okay. So let's practice. Can you get your pencil out and draw me 1/4? Can you draw me a quarter? Quarter of anything that you want. Okay, and I'm going to draw something up here. Okay, and when you're done with a quarter, can you draw me 5/6? Like, draw me a picture. What does that mean in real life? All right. Okay, did you get it? I'm still drawing mine. Okay. So here's 0. There are 3 possibles. Imagine these are evenly spaced. Okay, so here you ate no pizza. Here you had a slice. Here you had 2 out of 3 slices. And here you kind of pigged out and had the whole thing. All right, what did you draw me for 1/4? Oh, I'm seeing pictures from you. Excellent. So 1/4, I have pictures like this. Excellent. 5/6. Some people are drawing circles. Some people are drawing, looks like stacks of bricks, right? 5/6 would be 5 out of 6 of them are colored. Excellent. Okay, good. So you get an idea of what fractions are in the real world. Okay, good. So fractions can be expressed in number lines. For example, if I have a great big number line and here's the 0 and here's the 1, where is the 4/8? Where is that? What would you say? Okay, go ahead and draw me and then you can show it to me if you want. Where is 4/8? So here's 0 and here's 1. So what do I need to do? Well, I need to start dividing it, right? Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. 1 is the same as 8/8. Anytime you have a number on, if you use all the divisions over that, it's the whole thing, right? It's like you ate 8 pieces out of 8 possible chocolate chips. Okay, this is 0/8. So here's 1/8, 2/8, 3/8. Hey, there's 4/8 right there. 5, 6, whoops, I can draw, 7, and 8. Okay, so 4/8 is right here. So did you notice how the number of lines is decided by this number? Yeah, so whatever's on the bottom, that's how many divisions you have. You guys use these things all the time. You ever seen one of these things? Here, if I put it right side up. Yeah, the number of divisions, whether it's metric or standard, the number of divisions on the bottom will tell you how many lines goes from 0 to 1 inches. So if it's 32nd on the bottom, you'll have 32 lines between 0 and 1. And we actually spent a lot of time on that in our, I think it was week number 1 and 2 in fractions. All right, so let's get down to the good stuff. You ready? Now that we kind of have a feeling for what fractions are, let's take a look at adding, subtracting, multiplying, dividing. Which one do you think is the easiest to do with fractions? Which one's the easiest? Which one would you say? Adding, really? Are you sure? Oh, I'm sorry, Anton. Thank you very much. Adding, I would say, is one of the hardest ones to do with fractions. I'm going to say this is the easiest, and then this one. So these two are the easiest when it comes to fractions. These are hard. And they're not impossible, but you got to do these in order to do those. So let's do the easy ones first. What do you say? Okay, so let's take a look at a couple of examples. If I were to say 3/4 times a half, both of these are fractions. How do you do that? You get your hand and you go like this. Can you do that with yours? So whatever I'm writing down here, you write in your math journal with me. All right, just put your hand right on top. Now, what is 3 times 1? Yeah, this should be pretty easy, right? 3 times 1 is, here, 3 times 1 is 3. Excellent. Then you move your hand and you go like this. Okay, what is 4 times 2? Okay, 4 times 2 is 8. The answer is 3/8. There. Not that hard, right? Okay, let's try another one. What if I have 5, 6 times, that's supposed to be a 2. Hang on, let me get my eraser here. Okay, 2/3. Okay, let's do that one. So again, put your hand on the bottom. 5 times 2, shout it out. That's right, it's a 10. And what about this one? What is 6 times 3? 6 times 3 is 18. Good, there's your answer. All right, if you thought that was easy, let me see a smile. If you thought that was easy. Yeah, isn't that fun? Okay, good. Should we do the division ones now? All right, let's step it up a notch. Okay, how many of you have ever done one of these? Here's you normally, big old happy face. How many of you know how to do one of these? Let's see if I can do this. Does anybody know how to do a handstand? I would not be smiling if that was me. No, you don't know how? I would love to see a handstand if you have it. No, I can't do it either. Okay, yeah, grown-ups, kids usually can do handstands easier. Okay, so for this one, for division with fractions, you actually do handstands. Division. Okay, handstands. Okay, so what does that look like? That looks like this. Watch this. So 2/3 divided by 1/3. Okay, so another way to write this is 2/3 over 1/3. And this type of problem comes up all the time in engineering. You'll get a whole bunch of stuff on the top, a whole bunch of stuff on the bottom. There'll be fractions, there'll be decimals, they'll all be mixed up. So this is something that really does happen. So these are the same, these are equal. Question is, what do you do with it? Okay, so it goes like this. So you write 2/3, and then I don't know how to do a division by 1/3. I don't know my 1/3 multiplication tables, so I can't do it easily. However, I know my multiplication tables of 3. So watch this. I'm going to change this to a multiply, and I am going to give this guy a handstand. So if I flip him around, if I take the reciprocal, what do I get? 1 over 3 turns into 3 over 1. Now, can you do this multiplication problem? Absolutely. Your hand goes here. 2 times 3 is, shout it out, 6. Your hand goes here. 3 times 1 is equal to 3. 3 goes, now this is a division problem. This fraction, it's a tiny baby division problem. 6 divided by 3 is 2. So here's your answer. Okay, let's do another one. Okay, so suppose I've got 2 fractions, 3/4 divided by 1/2. What do? Well, we take 3/4, we put them down, right side up. Anytime you change the divide to a multiply, you have to flip the second one. Not the first one, but the second one. So you tell me, what do you get when you flip the second one? You get a 2 over 1. Okay, can you do this one real quick for me? What does that become? Okay, so 3 times 2 is 6. 4 times 1 is 4. And there's your answer. That's it. You just did division, like fraction division. Normally when people talk about division, most kids, their faces kind of looks like this. They're like, whoa, right? So, but now, how do you feel about division? Yeah, right? You don't look like this anymore. You look like, yay, this is easy. I can do that. Okay. Oh, sorry. I gave you a mustache there. There we go. Okay. So, all right. Let's take a look at how do you do it with adding and subtracting. Okay. Let's add and subtract easy ones first. Adding and subtracting. Okay. So if I have, let's do an easy one. 2 over 6 plus 3 over 6. What does this mean? This means out of 6 possible, and out of 6 possible, okay? So it means you have 2 here, and then you have 1, 2, 3. Okay. So here's the main thing you got to remember. The difference between adding and subtracting and then multiplying is multiplying, you multiply these numbers together, right? If this is a multiply sign. For adding, this just comes along for the ride. You don't add the bottoms. That wouldn't make any sense because you wouldn't add the number of divisions because the 6 is your denominator. So 2 plus 3 sections is going to give you 5 sections now out of, whoops, wait a minute, let's start with the black. Out of 6, 1, 2, 3, 4, 5, 6. So now I have these 2 plus these 3 out of 6. Do you see how it doesn't make any sense to add the bottom? The divisions stay the same. It's how many you've eaten or taken or added that in the out of the number of possibles that makes the difference. Somebody's asking, what if it's bigger? Okay, so suppose I have, let's do another problem. So 2 out of 6 plus 5 out of 6. Okay, so if the bottoms are the same, that's the first thing you always check, is you just carry it along for the ride, and then you just add the tops. What's 2 plus 5? 7, and that's your answer. That's it. So in real life, this would look like you've filled up all of those containers, and now you had to go run and get another one. Okay, so 6 out of 6 plus 1 more, which is 7. Okay, and the same thing is true for subtraction. If I have 5 out of 8 minus 3 out of 8, what do we have? Okay, so always look at the bottom first, the denominator, okay, and that just goes along for the ride for addition and subtraction. The top, 5 minus 3 is how much? Yeah, 2. That's your answer. All right, good so far, right? The trouble comes in when the denominator is not the same. Would you agree? That's where the trouble is? Okay, so yes, the handstand number with division turning into multiplication, yes, that is called a reciprocal. Good question. Okay, if the denominators are different, you have 3/4 of a cup and your sister dumped in a half cup. You need 3/4 of a cup of flour. She dumped in a half cup of flour. How much more do you need to put in? You know, she was trying to be helpful and she didn't use if you have a 3/4 cup measure. Okay, so these are different. You can't just go 3 minus 1 because these are different. Okay, so what does this look like in real life? So this means you got something like this. So because the divisions are different, you can't add them yet. You have to make the divisions the same. And how do you do that? Okay, so the easy way that'll work every single time is that you would multiply these two together. Okay, so I know you probably you probably see a shortcut, and that's great. But if you don't see a shortcut, just multiply these two together. So what does that mean? That means that for 3/4, what you're going to do is you're going to say 3/4 times 2 over 2. See, 2 over 2 is a clever form of 1, or it is 1, right? Anything over itself is 1. If I have 5 over 5, that's 1. If I have 99 over 99, that's 1. It means out of 99, I've filled up 99. So I've filled up the whole thing. So that's a whole. It's no longer a fraction. So over here, I can multiply numbers by 1 all day long and nobody cares. So that's what I'm doing here. I want the bottoms to be the same. So I'm going to multiply by 1. And the one I'm going to choose is I'm going to say, okay, this denominator, and I'm going to choose it for the numerator and denominator and say, okay, multiply by 2 over 2. So what is 3 times 2? 3 times 2 is 6. The bottom is 4 times 2, which is 8. Okay, now let's change this one. This was 1/2. I'm going to multiply it by the other denominator, top and bottom. So 4 over 4, not the 3, because I'm trying to get the bottoms the same. So multiply by the other bottom. So 1 times 4 is 4. 2 times 4 is 8. Do you see how they're both 8s now? So this method will work no matter what. It'll always work. Okay, so what do I have? I have 3/4 has become 6 over 8 minus, oh, you can't see that, minus a half. A half has also become an equivalent fraction of 4 over 8. 6 minus 4 is 2. Your answer is 2/8. All right, I know some of you are saying, but wait, you could have just scaled up this one, and that's true. That's true. Here, we'll do it that way so we can cover both methods. In math, is there usually more than one way to solve a problem? You should be nodding your head. Okay, this is one way. It may not be your favorite way. I want you to be fluent in lots of ways. That way, when there's a lot of ways in that sentence. When you have a problem, you have a lot of tools you can pick. And it's not if I can solve the problem, it's which tool should I use to solve the problem the fastest, the best, the quickest, right? The most elegant, whatever you'd like. Okay, the other way is to notice that 4 and 2 are related. Okay, so I have 3/4, and then I can scale this one up. Here, let's just look at the half. If I multiply this by 2 over 2, 1 times 2 is 2, 2 times 2 is 4. Now the denominators are the same. So if I can scale one of them up to match the other one, then I can do that. I don't have to touch this one at all. So 3/4 minus 1/2, which is also 2/4, is 1/4. Now if you're like, hang on, that's not the same, but look, this is 2/8. That was our answer from before. 2/8 is the same as 1/4. I can divide the top and the bottom by 2. Right? Divide by 2 over 2. This is like saying I'm dividing by 1 because it's 2 over 2. It's the same as 1. Nobody cares if we multiply or divide by 1. We care if you do any other number like 0 or 1,000,000, right? But we don't care if it's 1. And so if I divide this thing by 1, divide the top by 2, divide the bottom by 2, 2 divided by 2 is 1, 8 divided by 2 is 4. Do you see how they're the same? So there's many different ways of solving the same problem. And I want you to get good at lots of them. Lots of them. That's my goal for you. Okay, so I'm going to pause here and see how you're doing because we only have one more thing to talk about and then we're done. That's it. This is all of 7 weeks of fractions. Okay, so here, where's my face? There it is. Hi. So how are you doing so far? Let me see the expression on your face. How are you feeling about this? Yeah? Okay, I see lots of happy faces, lots of thumbs up. That's great. Okay. All right, so can we handle one more thing? Can we talk about improper fractions and mixed numbers? Can we do that? Okay, let's do that. And then it'll be open up for questions. You realize we've only been here 20 minutes. Look how much we've done in 20 minutes. Yeah, a lot, right? Anybody finding this good review? Yeah. Okay, then I have a couple more questions for you. And once we finish this, I'll also give you a story. Okay. All right, so mixed numbers and improper fractions. When I heard the word improper, I was excited because I thought it was like a fraction that was misbehaving. Yeah, so, all right. So have you ever baked cookies? And you'll see something like this. We need 2 3/4 cup flour. Seen that? All right, point to the whole number. There, and a fraction, 3/4. Okay, so this should not be a surprise. Okay. So if I want to get rid of the whole numbers, sometimes working with whole numbers is difficult, and I want the whole thing to be a fraction. So in order to do that, there's a really simple way of doing it. So I'm going to multiply these two together, and then I'm going to add this one. Okay, so what is 2 times 4? 2 times 4 is 8, plus 3 is 11. Carry the denominator. 2 3/4 is the same as 11 over 4. So this is the mixed number. This guy is called improper fraction. Proper fraction. Do you know why it's called an improper fraction? It's not because it misbehaves. It's because it looks like it's going to fall over, because the top is heavier than the bottom. This is a larger number than this. So if I had a number just like 3/4, people call that a proper fraction, but nobody really cares about the proper part, so they just call it a fraction. All right, so improper just means top is bigger. And can we still use it? Will it break math if we use it? No, not at all. We use them all the time. So we now know how to go from here to there. Can we do another example? If I have 1 5/8, what's the improper fraction for that one? So you take 8 and multiply it by 1. So that would be 8 plus 5. So I would have 13/8. Yeah? And that's it. Okay, so we're good here. How do we go the other way? Okay, I remember this was one of my favorite parts when I learned this in math. I think maybe 4th grade. Okay, so what you do is you take a bigger piece of paper. All right, so what you do is if I have 11 over 4 and pretend I don't know what the mixed number is, how do I do this? Okay, so do you remember this thing? Dun, dun, dun. How many people really don't like division? Yeah, okay, I get it, I know, and it's long and cumbersome, and I'm sorry. I actually, I like division, but because well, you'll see why. Here, so who goes in the box? The top number. Who goes outside the box? The bottom number. Remember how I said fractions are division problems? There it is. So if you need to memorize anything, just remember the top goes in the box. Top goes in the box, like the top of a cereal box, okay? All right. So 4 doesn't go into 1. So 4 goes into 11. How many times? It goes in 2. 2 times 4 is 8. And do we have a remainder? Oh, yeah. And that's it. Stop. I don't want you to go any further. You finished. What do you mean? Okay, so this is your whole number. So your answer for 11 over 4 is 2. And watch this. Write the remainder. 3 out of 4. So here's your 2, here's your remainder, 3, because if this was, whatever your remainder is, it's a part of 4 divisions. So 3/4, and that's it. This is your mixed number for this. Here, let's do another one. Okay, can you guys give me a few numbers? Can you type in a couple of improper fractions for me? Don't make them too hard, because you're going to be doing them. Okay, so the one with 1 million in it is too hard. Okay, so give me some improper fractions. Okay, so 13 over 6. Sure, we'll do that one. So who goes in the box? Who goes in the box? Here's your box. Okay, so the top goes in the box, bottom goes here. Does 6 go into 1? No. Does 6 go into 13? Yeah, how many times? 2. 2 times 6 is 12, with a remainder 1. Okay, stop. Now, what's the mixed number? So the whole number is 2 because it went in at least twice, right? It's a little more than twice. So 2, and the remainder is 1/6. Okay, now if I had a chalkboard, I could do this, but I can't, so watch this. What if instead of 13, it was 14? We just make it a little bigger. Okay, so this would now be a remainder of 2, right? Do you see how it changes? Here, we'll do another one. What if instead of 14, it's 15? So let's just inch it up a little more. It still only goes in twice, right? But now the remainder is growing. Do you see that? The remainder is growing. And so this becomes 3 out of 6. Are you seeing that? Yeah, okay, good. So whatever this number is, this is your whole number. That didn't change. But the remainder is what's here, and that's what I want you to see. Okay, great. All right, last thing with improper numbers and improper fractions and mixed numbers is adding and subtracting them. Okay, so if you want to do stuff with numbers, which is really what we use numbers for, suppose I've got this. All right, everybody go like this. Yuck. You got it? Yuck. There you go. Okay, let's just get it out of the way. All right, so here we go. It's a yuck because they're big numbers and these don't match. The 4 and the 8 don't match. Okay, we have 2 different options for solving this one. Option number 1, you go like this. 2 3/4 minus 1 5/8. And you do it that way. So, but because, okay, so you can subtract the whole numbers and then you subtract the fractions. And we've already talked about subtracting fractions. Here, let me put it here. So this would be 3/4 minus 5/8. Okay, so you're gonna have to scale this one up, right? Because the 4 doesn't match. So if you multiply, so the 3 over 4, if you multiply it by 1, so 2 over 2, times 3 over 4, I get a 2 times 3, which is a 6. And this is an 8. All right, so now 3/4 has become 6 over 8 minus 5 over 8. So you tell me, what do we get? I have 6 8s and I subtract 5 8s. I have 1 8. Okay, and 1 from 2 is 1. So that's one way to do it. Somebody's asking, what if it had been 4 8s? Okay, that's a good question. So let's pretend this is on top, this is 4 8s. Okay. So if it's 4 8s, our answer is going to be different, okay? All right, I have to borrow, right? Just like you do regularly. But what do I put here? So this is a 1, and I'm borrowing 1 because this goes from 2 to 1, so that other 1 has to go somewhere. So I'm going to add, oh, I should have used another piece of paper. So I'm going to add 1, which is also known as 8 over 8. So 4 plus 8 is 12. So now I have 12 8s on top and 5 8s on bottom. Do you see that? So that's how you would do this one. This is messy. I prefer the other method. Can we do the other method? Here, watch this. 2 3/4 minus 1 5/8. Let's turn them into improper fractions. Okay. 4 times 2 is 8, plus 3 is 11 over 4. Minus 1 times 8 is 8, plus 5 is 8 plus 5 is, 13? Did I get that right? Okay. Do you see how this one's a lot easier? Yeah. So usually when you subtract or add mixed numbers, usually you do it when you change them to improper fractions. All right, so which one do we need to scale up? Yeah, that one, right? So let's multiply by 2 over 2. Okay, 2 times 11 is 22. 2 times 4 is 8. I now have 22 over 8 minus 13 over 8. And the answer is, anyone? What's the answer to that one? I got an 8 on the bottom. I'll do that part. If this was 23, would it be easier? Okay, so it's not. It's 22. So 10 minus 1 is 9. And that's it. That is the last thing I'm going to cover, unless you want to convert this into an improper fraction. Here, watch this. I'm sorry, into a mixed number. So the 9 goes here, the 8 goes here, 8 goes into 9 one time. Stop. This is the whole number 1, and this is the 1 over 8. Same thing. All right, we did it. Yay! And it's exactly 9:30. Look at that. Half an hour to do 7 weeks of fractions. All right, yay! All right, how are you feeling? Okay, well, first of all, wait, let me back up. How many people would love it if you could just watch me do math and then it would just be in your head? And you would have nothing to do. You could just sit back and watch. Wouldn't that be nice? That's what everybody wants. Okay, so, all right, so I'm here to tell you that you can't just sit back and watch. You have to actually do the work. I'm the one doing the work here because I'm explaining it to you. So guess who has the knowledge so far? Me. And I want to tell you this because it ties into a story. To begin with, I was terrible at math. I was not good at it. In fact, I almost decided to quit school at one point when I was in college because the math was so hard. And I had some advice. This is part of your story. So I got some advice from a professor. He kind of took me aside and he's like, hey, I know you're struggling quite a bit. Like, what's going on? And I'm like, I didn't realize how hard this was. And I forgot what he told me in that moment. He basically said, he goes, look, I know you know the skill. You couldn't be in this college if you didn't have what it took. He says, you just need to take it slower. Just take it. Slow is smooth. Smooth is fast. He goes, take it slow. Don't try to rush it. Don't compare yourself to other people. Just do your best. And then that's from there is where I got Aurora's 2 rules for success. Do you remember these? All right, rule number 1, I succeed in anything I do if either one of these is satisfied. So not both, but I could do either one. Rule number 1, if I try my best, then I am successful. So notice where that puts the success. It puts it in my arena. It doesn't mean, I didn't say I'm successful if it's sunny outside. I mean, can I control the weather? I mean, I wish I could, but I can't, right? So I'm successful if somebody else thinks I'm good at something. Well, that means that I'm only successful if somebody else has a good opinion of me. And I don't want that either. So that's why I pull it back into my own circle of influence. And I say I'm successful if I know I did my best. And then even if I got the wrong answer, I learned something. And that's number 2. Either I did my best or I learned something, and usually I hit both of them. So if I can always learn something. In fact, do you remember that story I told you where I went into the most boring class ever and I was the only one writing notes? It's because I was writing notes on what not to do when I became a teacher. I have this belief that no matter what it is, even if it's the most boring thing on the planet, there's something for me to learn here. And so that causes my brain to focus in different ways that I wouldn't normally be focusing. So there you have it, Aurora's 2 laws for success. And and I'm going to give you another story too, don't worry. Okay, so I just want to encourage you, yes, I know it's hard work. Yes, you can do it. And just take it slow. A lot of, especially with today's level of technology, it's really easy to just feel like, oh, there's just, why should I even bother? But it matters to me because the work you do is important. And that's why we do so many practical applications, because the work that you do matters because it matters to you. And it's like you're climbing a big staircase of your life. And every day you get to go one more step. And then if you look back yesterday, you're like, ooh, boy, that was a big step. Glad I don't have to do that one again. But now you're already one step higher. And so I'm here to support you with that. And so that's why we have study halls with Leah. That's why you have Doug on Thursdays, usually, except tomorrow you have me, because I'm substituting for him. And that's why we have lots of support for you. So it's supporting you where you're at. Yeah. So how's that? Yes? How are we feeling about fractions so far? You feeling like you could teach it to somebody else? Yes? All right, so let me scroll back a bit and let me ask, or let me see what your questions are. Let me get myself a cough drop because I'm still getting over this cough. Never seen my hair in a ponytail. Okay, so what do you think? Yeah, it looks like I've got no hair, right? It's because today's a video day. And I'm constantly like this and I don't want my hair all over the place. So video day is ponytail day. Okay, questions. Fractions, are they really used in real life? Yes, they are. So what you want to do now, here, let me show you on the website where to go. So if this is where you are at with fractions, if what we covered today is exactly where you are, that's fantastic. So what you do is you go to the website and you click on this word that says fractions, okay? And then what you do is there are workbooks, and this is the backbone of the, the backbone of the course. And so you click on a workbook, and there are 4 workbooks. Each one has an answer key. And so if you're not sure, like, well, which workbook do I need? So what I would recommend is open up one of the workbooks and then go to the very last page, the last 2 pages. And there are assessment tests. It's basically a little practice test that covers everything that we had covered in the book. And so if you can complete the assessment without hesitating, you get most of them right, then you know you've graduated from that book. And so every book has one of these. So you can do this for any one of the 4 fractions, okay? And then what I'd recommend, even if you've tested out a fractions workbook number 1 and number 2, what I would recommend is go back to that fractions page, okay? Is click on fractions week number 1, okay? And even if you're already past this, just bear with me for a second. At the top, there's always an intro video for parents. This tells you what to expect, what we're going to cover this week, what the different handouts are, what your child is going to learn. Usually the video is about 3 to 5 minutes. Sometimes they're longer, especially at the beginning of a new unit. And then here's what I really want you to get. This is the assignment outline. There's one of these for every single week, okay, every single session. And if you're a beginner, meaning you've never seen this concept before that we're covering that week, then you start at the beginner level, and I give you workbook pages to do. I don't know if you can see it here. There we go. Then I give you workbook pages to do, and then if you've seen the concept, or even after doing the workbook pages, you're like, oh, okay, I think I get it now. Now you're ready for hitting that concept in different ways, and then that's what the intermediate level is. There's ice cream shop. There's usually games and projects and so forth in the intermediate level, and then I would pause. And then once you finish that, go to fractions week number 2. And then it's got the same format. It's got the parent video, and it's got a new assignment outline, which is different than last week's. See, we have a pizza place activity. Now we're in 2 workbooks. Okay. And so you're going to continue from the beginner and then move into the intermediate at your own pace. And then once you finish all the way through fractions week number 7, what you do is you go back to fractions number 1. So you finished, say, all the way up through fraction 7, go back to fractions number 1, and now you can go do the advanced level. So the advanced level assumes you've already mastered the concepts in fractions. Advanced is practical application of all fractions concepts. So it's a little difficult to do it just after you've only had like 1 lesson in fractions. So do the beginner and intermediate level for most of those, and then scroll down and you will see projects and labs in the advanced section. So this is what labs are and how to do them. You'll download the lab, and so there's labs in real things. Like this one, for example, there we go. So this is an aerial photo of 2 humpback whales, and using fractions, you're going to scale the photo up and tell me how big the baby is. So this is a real practical application of what we just covered in fractions. And here's a condor
to get the one
we went for
leading you through the first part. It says make 2 marks.
Sorry. We went for a nature walk, and you snapped a photo of a condor. And I'm asking you, how big is the wingspan? So this is something you would be doing if you were like a ranger or a biologist in the field. And then there's a harpy eagle one. This one's a little trickier.
Okay, now if you measure,
because you didn't get the whole harpy in the whole eagle in the shot. Like, how do you do that if you don't have the whole animal? So that one's a little trickier. And then if you are into astronomy like I am, I try to include some astronomy in a lot of the weeks, not every week, but a lot of the weeks. And so we talk about moons and planets, and these are all real labs and with real data in them. And so we are scaling different planets and looking at the sun and the stars and how big galaxies are. And then every week, as you know, has a math challenge. The math challenge isn't necessarily the related to what we talked about. Sometimes it is, but sometimes it's just something that you and your family can discuss around the dinner table and just have some fun doing. Okay, so that's where you go from here. So go into fractions, take a look at the workbooks, take the assessments at the back, and then figure out kind of where you are. And then every week there's games and challenges and projects and fun things to do to really make this learning thing fun, because we're in this for the long haul. We don't want you just to like hate doing math. We want you to love it so you come back and do more. So that's what we really want. Okay, other questions that are coming in. I'm looking for math questions. Okay, other questions. Let's see. Please tell us this class is recorded. Yes. Oh, did I make a mistake on one of my calculations? Somebody is saying I did. You did 15 instead of 13. I'm sorry. If I made a mistake, correct it for me. I have no problems if you guys, if you correct it. All right, you guys ready for a story? All right, that's it. It's at 9:40. We are done with class. Yay! Okay, story time. Just show me with your thumbs up, okay? I'll give you 2 different options and then you pick. Let me tell you the 2 options first. Okay, so option number 1, I can tell you the cookie story with fractions, the runaway class, which you may have heard before. Okay, so but I know we have a lot of new friends, so I'm trying to figure out what would be best. That's option number 1. Okay, so that would be 1. And then option number 2 is I actually have oh no, I don't have it here. I had a Richard Feynman story I was going to share with you. Oh no. Okay, wait, I got to think of another one real quick. Think of another one really quick. Oh, I know. Aurora as a student in a math class. So would you like Aurora as a student in her own math class, or would you like to hear about the ice cream? All right, you're going to need your videos on if I'm going to see you. Okay, I think I got more. It's even right now. Uh-oh, we need a tiebreaker. 1, 2, I see 1, 2, 3, and I see 3 2s and 3 3s. Oh no, what are we gonna do? Okay, I guess I get to pick. Do I get to pick? No, I don't need to pick. Okay. All right, it looks like I have more 2s. It looks like Sophia, you're voting twice. That doesn't count. Okay. All right, Aurora as a math student. All right, here we go. So once upon a time, there was a young student. Here, let me make myself bigger. Where am I? There we go. Okay, there we go. Well, first, did you guys like this? How did you guys like the review? Did you guys like it? Okay. Oh, other question before I get started, because I don't want to forget to ask. For those of you that worked through, well, I don't know if anybody did yet. Did you like it that I made a video, or do you think you would like it, a video of me working through the entire workbook with you? So whatever the workbook is, there's a huge long video. What do you guys think about that? Because I did that last week and I'm going to do it again this week, especially for algebra. You like that? Okay, so we'll continue. Those videos are long. It was 3 hours for this next one. I know, you're not supposed to do it all at once. That's the whole workbook, right? The whole thing. So you're supposed to just do I broke it into pieces, but okay. All right, well, we will continue that. All right. Okay, so this will be fun. All right, so once upon a time, there was, excuse me, there was a girl with no water. Oh no, where's my water? Hang on, let me grab my water. Okay. I know, I'm still recovering from my cold. All right, so I am in, I want to say 4th grade. Yeah, I think it was 4th grade. Might have been 5th, but I think it's 4th. And so I'm in 4th grade. And remember how I said I was really struggling with math? All right, so true story. I wasn't always great at math, but one thing I was really good at was working really hard. And so you ever seen like a bulldog? And as soon as they grab onto something, they're like committed, right? You don't want one of those guys committing to like biting your leg, right? That would be bad. So I've always felt like if I've wanted something, I would not let go until I got it. So think of like a 2-year-old who heard that they were going to get ice cream and it hasn't happened yet. So think about like that, right? That kind of commitment. Okay, so here I am. So even though I'm not smart at math, like in terms of I can just know it. I just work really hard to get what I've got. And so I hope you can see that difference. So there are people that can just do math and they just get it. And if that's you, that's fantastic. I've always wanted to be you. And then there are other people who, they just work really hard. and then it makes sense, but it takes a while. And so that's me. That's where I am. And what you're seeing when I teach class, it may seem like, oh, she's such a genius. What you're not seeing is 40 years in the making of practicing. Okay, so, all right, so rewind the tape. I'm 10 years old, if you can imagine that. All right, so I'm working really hard, and we get to some part in math where it completely just makes no sense. It's like the whole thing's in Latin, and I have no idea what it is, right, or Greek or something. And so I take my little math book home, which we're not allowed to do. I went to a private school where everything always had to stay at the school. And so I take my math book home, and I got in big trouble for that, by the way, for studying. And so I took my math book home, and I was at that thing all night long, and I was trying and this is before, no internet, the library was closed. If you wanted something, you had to go look it up, right? And so all I had was my math book. So I remember wrestling with it for a long time, and I wasn't studying with anybody else, which I should have been. And by the end of the night, I don't know, I think I was up in the middle of the night, and I used a flashlight and under the covers, right? And I'm looking at a math book. And so I worked and worked and worked at it, and finally I was getting the answers in the back of the book. I'm like, I think I see a pattern. I think I got this. So the next day I show up, and the teacher goes, okay, we're gonna have a math test. I'm like, yes, finally, I studied for something. I didn't mean to. It was like a pop quiz, right? And she goes, everybody put away your pencils. And we're all like, what do you mean? Well, put away your usually it's take out your pencils. She goes, okay, and then put away your backpacks and put away all your books. And we're like, okay, this teacher has lost it. And so she says, okay, now stand up. And she brings out a giant beach ball. And this school was not known for being cool like this at all, like ever. So it was a total surprise. And so she tosses the ball, and she points to me, and she points to another kid named Mike, and she says, okay, you guys are captains. And I'm like, captains? I've never been captain of anything in my life, right? I'm usually the last picked on the team. So, because I'm so little, right? As a kid, I was always the littlest one in the whole class. So she goes, you guys are captains. I'm like, oh, I'm a captain. I'm like, we're going to play kickball. This is going to be awesome. I completely forgot she had said we're going to have a math test. And she goes, okay, you guys, these are our math teams. I'm like, math teams? I am a captain of a math team? I'm like, it's not even anything cool like softball. I'm like, okay, fine. All right, so I'm captain of a math team. I'm like, all right. So I'm looking at Mike, and he's like, I don't know what's going on. So they said, okay, pick who you want. So I'm realizing I should not be picking the most athletic kids, right? Because if this is a math thing, I want the kid that aced the last class, right, or the last homework. So I'm looking around, and so we get our teams, and nobody knows what we're doing. And so I get this. So back then, the chalkboards, excuse me, the chalkboards are huge. And so the chalk had its own holder, and it's like enormous, especially in like a little kid's hand. It's like trying to hold on to it, like the biggest, fattest marker you can imagine. And it had the thing on the end, and you push it, and the chalk like advances. It was like a giant mechanical pencil, but for chalk. So we each got one of those. And she goes, okay. So everybody starts in the back of the room, and it's a relay race. And she goes, you got to run to the board. I'm going to tell you the problem while you're running for math, and you solve it on the math board, and then you come back. Sorry, hang on a second. And so I'm like, okay, I got this. And it was all the problems I had just studied the night before, every single one of them. Like she had taken them from the book, and I'm like, oh, I so got this. It just happened. It's like you read a book and that's what everybody else is talking about. And you're like, oh, I'm so knowledgeable. It just happened to line up. It's not like you're so brilliant. The opportunity was there, right? So the other students were struggling because it was a new concept anyway. And so I'm like the captain. I'm like, okay, you got this one. So do this, and then divide by here, and then multiply by there. And they're all looking at me, and they're like, wow, she's really smart, right? I'm sitting there. I'm like, it had only been because I stayed up all night the night before. And so, of course, we won. Yay! So I was champion math. What do you call it? I was the captain of a champion math team. All right, so there's a postscript to this. So we go out for recess, right? And now like I'm all popular and everything for like 10 seconds. And so we go outside, and the kids are like, let's play kickball. So we're going to go play kickball. This is why I remember this one day, okay? So we go to play kickball. Did anybody ever play kickball? I don't know why it's not a sport. It's like the coolest thing ever. I know, right? Kids know this. Grown-ups don't. I don't know why. All right, so we're playing kickball. And there's that one kid. This is the one kid who, as soon as they come up to the plate, everybody backs up like 3 miles, right? And there's this one kid that they know you can, so her name was Michelle Vargas. She comes up to the plate. She kicks it. It goes clear over everybody's head, even though we've already backed up. And I remember watching it, and I look up, the ball goes in front of the sun. At that same exact second, I kid you not, we had a solar eclipse. We looked up, and I'm like, oh shoot, what did she do to the sun? Right? I'm a 10-year-old. I'm looking up, and I'm like, the whole thing just went black. And so we're all standing there. Everybody has forgotten about the ball. We're all standing there, and we see the corona, and the sun is black. And we're standing in the sun. We're standing in the shadow, right? The moon has crossed in front of the sun, and the moon's shadow is right what we're standing in. So the moon looks black. And I'm like, oh, we're going to get busted, right? I am certain we're going to get in trouble, right? I'm like, she did something, right? And so we don't know what's going on. We had not learned about this in science. Science back then was considered something you did once in a great while. We all run like crazy and try to find a teacher. And we're like, we did something, we don't know what it is, but there's something wrong with the sun. And the teacher looks up, I kid you not, looks up and goes, don't worry about it, it's not important. I'm like, are you kidding me? People pay thousands of dollars, travel around the globe to stand in the shadow of the sun. They're eclipse chasers, they're real people, right? So we're like, no, I'm pretty sure this is important. Like, this is something big. And she goes, no, I want you to study for your next math test. You did really well, I want you to go study right now. And I'm like, are you kidding me? So we all go back to the classroom. And so we're all sitting down and we're all chit-chatting. I'm like, I don't know what happened. We've never seen, none of us had ever seen an eclipse. We didn't study astronomy back then. It just wasn't done, right? And remember, no YouTube, the only way we got information is if we hear it from people or we read it in our textbook. That's typically how it's done. And then the TV shows weren't really educational. There was like that one PBS, and that was it. So, and I didn't watch TV as a kid anyway, so it wouldn't have mattered. So, so we get back in the classroom, and we're all chit-chatting, and the teacher gets so mad at us, and she's like, will you just stop talking about it? Nobody cares. It's not important. She goes, let's get on with our lesson for today. Okay, and she turns back to math. And I remember thinking like there's something wrong here. Like, there is something wrong. And at that moment, I took out my science book. I flip it open, and there is a picture that Voyager 2, I think it was Voyager 2, had taken of Saturn. And I remember looking at that picture, and that was the moment I was like, that's what I want to study, this astronomy. That's the moment. And so there you go. You've got a longer story today. Yay! And so that was the first moment I saw Saturn, and I'm like, in a textbook, I'm like, I want to see it for real. Like, this is what I want. Not what the teacher is blabbing on about that I'm going to forget about, right? This is what I want. That's why we do so many practical applications, because it is important. Would you agree? So what would you have done if you were me, right? And you were a kickball, and suddenly the sun went out. I mean, what would have been your thought? Like, like you guys are smarter than I am because you have access to more information than I did back then, right? Right. So you have more information than I did when I was your age. So what would you have thought? Okay, yeah, you would have. If you didn't know what a solar eclipse was, though, what would you have said? Is it conceivable? Like, you're like, I did something, right? What would a little kid think? Yeah, I did something. I'm busted, right? The world's coming to an end. Yeah, there was that one kid that kept saying that and going around in circles, but nobody paid attention to them. Okay, so, all right, yay! So there's your story. Anyway, I just want to encourage you, if you're struggling with the math bit, I've been there, I totally understand, and just work at it a little bit at a time. That's all. Do your best and learn something new, and then every day, that's what progress is for. We're in it for the long game. By the end of the year, I want you so excited about math, you don't even care if you know something or not, because you will have the ability to figure it out if you don't know, because that confidence will be there. And that's what we're really after. All right, I'm gonna say this has been super fun. We're gonna do the next one next Wednesday, and it'll be just on decimals, and we'll have the same format. We'll have some time together, different set of problems, different concepts covered. All right, everyone. I'm gonna pull out my camera. So cameras back then were huge. All right, everyone, I will see you soon. Get to work on your math. All right, bye-bye. Let me know if you have any questions. You know my email by now, aurora@superchargedscience.com. I'll see you next time. Bye-bye.